Okay, let's continue with another subsection, which is of bending of members made of several materials. For example, you have a beam. You have a beam, but the beam is actually made from two types of materials. For example, so perhaps maybe top is steel and this one is brass. So this is a combination of two materials. So and then this beam is subjected to bending. So how you want to solve this kind of problem? If you want to find the shear maximum, something like that, shear maximum is equal to MC over I. So how you are going to do it, because this involves two types of materials, not like before. Okay, so the answer is how you want to solve this problem is you convert one material to become another material. For example, you convert steel to become brass, so the whole structure will become brass. For example, steel you convert to become brass and it will become like this. So similar to this beam, this beam consists of material 1 and also material 2, and the neutral axis is here. So in this case, material 2, so this material 2 and this is material 1, so it has a different color to represent different types of material. So in this case, material 2 has been converted into material 1. Material 2 has converted into material 1. So all become blue like this. So when material 2 become material 1, this area is getting bigger. So how you want to convert is you have to find the value of n by, if you want to convert material 2 to become 1, you find the value of n by dividing the elastic modulus of material 2 to the elastic modulus of material 1. If you want to convert material 1 to become material 2, you find the value of n by dividing elastic modulus of material 1 into elastic modulus of material 2. So see this correlation. So 2 to become 1, you divide elastic modulus 2 to elastic modulus 1. 1 to become 2, you divide material 1 to become elastic modulus 1 to elastic modulus 2. So you will get the value of n. Okay, so this is the equation. So in this case is material 2 to become material 1. So you get the value of n. Okay, looks at this example 4.6. So this bar or this beam is made of two material, steel and also brass. Okay, so this is steel, this area, and this is brass, this one and also this one. So you look here, brass and steel, this area for steel. Okay, but it's made from bonded pieces of steel, which is elastic modulus steel is 200 GPa, and brass, elastic modulus brass is 100 GPa. So determine the maximum stress in the steel. So what is the maximum stress when a moment of 4.5 kilonewton meter is applied? So MC over I. So M is equal to 4.5 kilonewton meter. So C is half, which is 0.0375. So this 75 mm. So this is M. So C is 75 over 2. So you get 37.5. meter or 0.00 0.0375 meter. Okay, so what is I? So I is 1 over 12 BH to the power of 3. But because B is from different material, so we need to convert either brass to steel or steel to brass. So let's say this one is 1 and this one is 2. So let's say you want to convert 1 to become 2. So 1 to become 2, you find N is equal to E1 over E2 because you want to convert 1 to become 2. So E1 is ES. E1 is, this is steel. So steel is 200 over elastic modulus 2, which is brass, which is 100. So you get 2. So this will become 2 times. So this one is 18. So this one you need to times by 2. So it will become 32. So if you see, 18 times 2 is 36. So this one, initially it was 18, but because you find the value of N is equal to 2, the value of N is equal to 2, so this one 18 times 2, you get 36. So now you convert steel to become brass. Okay, you convert steel to become brass, so you will get this, the new B. This is the new B base, so that you can calculate I is equal to 1 over 12 BH to the power of 3. So B is equal to 36 plus 10 plus 10. So you get 56. So you calculate I, 56 times 75 times to the power of 3, and then you will get this value. And then you calculate the value of maximum shear. This is moment, this is the C, this is the I, and then this is the value of the shear maximum for brass. Yes, so if you want to find the maximum, the shear maximum for steel, you just times by 2. Okay, because steel is 2 times than brass. So you get 171.4 MPa. Okay, similarly, in concrete, so you have this concrete, this is concrete, and you have this is a steel rod. Okay, so similarly, if you want to find the value of shear maximum, you need to find where is the neutral axis first. Okay, you need to find the neutral axis. So you have to convert this steel rod to become concrete. So when you convert the steel to become concrete, then the whole structure will become concrete, because you already converted the steel rod to become concrete. So after that, you need to find where is the area of the neutral axis, where is the line of the neutral axis. Okay, so to determine, so the conversion is similar. You convert using this equation. N is equal to elastic modulus steel over elastic modulus concrete. So this is if you want to convert steel to concrete. As I said, 1 to 2, so steel to concrete. So to determine, after you know this, to determine the location of the neutral axis, you use this equation. So Bx times x over 2 minus NASD minus x. So if you multiply with this, you will get B half Bx square, and then this one, if you times with this, and then you time with this, and then you finally will get the equation like this. Okay, the normal stress is calculated using the same equation. Okay, let's have a look at this example. Problem 4.7. So a concrete floor slab is reinforced with 16 millimeter diameter steel rod. So this rod is 16 mm diameter. The modulus of elasticity is 200 GPa. This is 200 GPa and 25 GPa for concrete. So this is concrete. The concrete, and then the modulus is 25 GPa. With an applied bending moment M, this is M is equal to 4.5 kilonewton meter for 0.3 meter width of the slab. So from here to here, determine the maximum stress in the concrete and steel. Okay, so you need to transform this steel into concrete first by finding the value of N. ES over E concrete, so you get 200 GPa over 25 GPa. Okay, so you get I think 8. Yes, you get 8. Okay, so when you convert, you get the new area, area for the concrete is 3216. Because the area of steel is pi r square times 8, or and then times 2 because in 0.3 meter width, there are two steel rod. So steel rod 1, steel rod 2. In 0.3 meter width there are 2, so that's why you times by 2. So that's why you times by 2. And this one you can use pi over 4 d square, or you can use this is the area, or you can use this equation pi r square, and then you need times by 2, and also this one also you need to times by 2 lah. So either which equation that you want to use. So in this slide they use this equation, which is this one, pi d square over 4, and then times by 8, because 8 is this n. Okay, so you get this is the area for the steel. Okay, and then you find the location of the neutral axis. So from what you get here, and then from what you get here, you put into this equation. Okay, you put into this equation, and then you will find x. So x is the location of the neutral axis. So in this equation, it is known that x is 36.8 mm neutral axis. So this is 36.8. So to find I, similarly like before, I is 1 over 12 BH 3. So 1 over 12 is B is 300, this one, H is 36.8 to the power of 3, and then plus AD square. A area is this one, this is the area, and D is the distance of the steel rod to the neutral axis. Steel rod that you have converted into concrete. Okay, this is steel rod that you have converted into concrete. So this is the area 3216, and this is the distance. Okay, so the distance is 100 minus x, which is x is 36.8, so this is equal to 63.2. So this is the 63.2, which is the distance. So you get the value of I. So when you get I, you know what is M, which is given as 4,500 in the question, and then the value of C occur for the concrete is 36.8 from here, and then you can find the value of stress maximum in the concrete, and then in the steel you can use this equation. So N is 8, 4,500, and then the distance or C is 0.0632 and I is the same, so you get this value. Stress concentration. So similarly like in the chapter torsion, so if you have a location of a different diameter like this, different diameter rod, so this area where it is sharp will cause a very high stress concentration. So in order to reduce the stress concentration, we introduce fillet, in which that the fillet has a smooth surface like this. So in which that this has the value of R. Okay, so you need to find, in order to determine the maximum shear stress is still the same, MC over I, but we add with the value of K. Okay, the value of K in front of the equation. So K can be found by using the same method as in the chapter 3, which is torsion. So K, first you find what is D over D. So this is D and this is D. Okay, or this is D. And then this is K. Okay, so to find K, first you need to find D over D. And then the second, you need to find what is R over D. So you know what is R here, what is the value of radius, and then you know what is the value of D, and then you can determine what is the value of R over D, and then you find, for example, let's say you get R over D is 0.15, you bring the graph top, and then what is the value of D over D. So if D over D is equal, for example, 1.2, so your graph intersect here, and this is the value of your K. So you just multiply with K, the value of shear maximums. Okay.